Hello, this is Mr. Wolf. Today we'll be doing geometry benchmark number 35. I can find the volume of prisms, cylinders, spheres, cones, and pyramids. Just a couple reminders before we begin. You must take a page of notes and show that to me in class to verify you watched the video, and feel free to pause and rewind as needed. This is for your learning. Okay, so we talked the other day about how we've been in the second dimension all year. All of our shapes have been, and now we're just now getting into the third dimension. So this kind of gives us an image of what we're talking about. You're already familiar with the x-axis. You're familiar with the y-axis, and what we've done now is we've added depth. Sometimes that's called the z-axis, but you can see now that's where we get the third dimension. Length, okay, height, and depth. All right, and we use volume every day. These are just some examples of where you might see volume. Anytime you go to the grocery store or you go to the soda machine and buy a drink, you're probably thinking about how much am I getting. That's usually in some sort of volumetric measurement. If you ever gone to a pool, the amount of water the pool holds is a volume problem. If you go to the movies, popcorn comes in different volume containers. Cereal comes in different size boxes, so different volumes. And this thing down here, that's the gas tank in your future car, and you're definitely going to be interested in how much gas that thing will hold. So keep in mind as you're learning about volume, this is something that we use in our daily lives. When we did area, we learned that if we took the length and the width and multiplied them together, we would get our answer for area. So for example, on this problem, 4 times 12 is 48. Okay. Now that we're doing volume, we add the third dimension, so length times width times height. So in this case, we've got 4 times 12 times 3. Okay. And that turns out to be 144. Whoops, 144. I'm sorry, I'm using a new toy here to write, so bear with me as I learn how to do it. Let's see if I can do that again. 144. Okay, we're just like up here, we would have said meters squared, or maybe feet squared. Okay, down here, now that we're doing volume, we're going to be doing meters, but not squared. There'll be meters cubed, or centimeters cubed. Okay? So that's the difference. Since we have 3 dimensions, it's cubed. Since we have 2 dimensions, it's squared, and that should make some sense. These are all the formulas you'll need for this unit. What we're looking at are all the volume formulas. So here, 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 and here. Okay, so I would suggest you pause. Write down the name of the shape, draw a picture of the shape, and then write down the formula for volume. And I want to make sure you understand that this says volume equals length times width times height, and then they break that down in case you don't know. They say furthermore it equals length times width times height. Okay, so as you work your way down here, you'll understand that. Remember, big B stands for the area of the base. Big P stands for perimeter still. Okay, get those down. We're going to go through and explore each one of these separately. First, we're going to start with volume of prisms because those are probably the easiest. We just did an example of one, but let's do another one here. This particular prism we're looking at is a rectangular prism. And for rectangular prisms, it's really easy. We just do length times width times height. Okay, so in this case, we're doing 10 times 5 times 6. Which equals 10 times 6 is 60, times 5 is 300. And in this case, it'd be inches cubed. Okay? So that's a rectangular prism. Those are really easy and simple. When we do a triangular prism, it changes just a little bit. Okay, the formula for volume of triangular prism is just big B times H. So that's the base area times the height. And you'll remember that the bases are the two shapes that are congruent and parallel to each other. So in this case, these two triangles. All right, so the first thing we need to find is the area of our base. So we'll do 7 times 8 divided by 2. 7 times 8 is 56. Divided by 2 equals 28. And then we do the big B, which is 28 times our height. And our height is our distance between the two prisms. So in this case, our height is 13. We do 28 times 13, and we get 364. Okay, so that's how we do a triangular prism. We could have any other shape of prism, though. Here's another triangular prism we could do. Here is a trapezoidal prism. Trapezoidal, that's a weird word. But then the same, it's still going to be big B times H. Okay, so big B for a trapezoid is going to be base area, and we're talking about this trapezoid. So this is the base right here. Area of a trapezoid is base 1, which in this case is, hold on here. In this case is 8 plus base 2, which is 14. All of that divided by 2 times the height, which is 4. Now we're just dealing with the yellow part, the trapezoid. Okay, 8 plus 14 is 22, divided by 2 is 11, times 4 equals 44. This is our big B, our base area. If we go back up to our formula, now we take that 44, multiply it by the height, which is 10, and we find that our volume is 440, in this case, centimeters, what? Oh, you're right, centimeters cubed. Great job. And if you'd like to do this triangular prism here, you can pause and do that for practice. Next, let's do volume of cylinders. The formula is big B times H. That should sound familiar by now. Base area times height. And just so you get an idea of what that looks like, here's an image of a cube. And when we talk about volume, what we're talking about is how many cubic units or little cubes would fit into that space. All right, and you can see here, how many unit cubes did it take to form the bottom layer? Well, in this case, it took 9 to form the bottom layer. Okay, and then how many of those bottom layers would you suppose? Well, it looks like about 3. So 9 times 3 is going to be 27. And there we can see that it actually does fill up. So that's where we get our formulas for area of the base times the height. All right, if we flip right back here, we've got big B times H, and our big B is actually a circle. Our bases are right here and down here, and those are circles, so we got to use our circle formula. Our circle formula is pi times radius squared. In this case, our radius is 2, so we end up with 4 pi, or 12.56. Okay, so there's our big B right there. And all we've got to now do is take our big B and multiply it times our height, which is right over here, 4. Okay, if we do 12.56 times 4, we get 50.24. And it looks like our units are centimeters and cubes. So 50 cubic centimeters, that'd mean 50 of these little cubes would fit into this particular cylinder. Okay, and here's another one you can do for practice if you want to pause. You just apply the same formula. Okay, so far we've done prisms. All right, all prisms are big B times H, or base area times height. Rectangular prisms, we do have this formula you can use, length times width times height. But if you'll just think about it for a second, length times width is the area of the base. So really, these two formulas here are the same. This one just breaks down what big B is. Okay, I hope that makes sense to you. Let's move on to a sphere. The volume of a sphere is a little bit different, and it's a 4/3 pi r cubed. 4/3 pi r cubed this time. So let's go ahead and try that. In this case, it looks like our r is 4, so we would do 4 4/3 pi times 4 cubed. All right, now I can do 4 cubed, but the rest of that's going to make things a little tougher. So let me get out my calculator here and do 4/3 times pi times 4 to the third power. And just as I suspected, it's a little bit bigger number. It is 268.1. Okay, so there, whoops, well, you get the picture. There is our volume of our cube, 268.1. All right, and then there's another one down here, but what's the difference? You guessed it, it is half of a sphere. So once we do our formula, 4/3 pi r cubed, guess what we're going to do? I hope you said divide it by 2. But once we get this answer, using this, we'll just divide it by 2, cut it in half, and we're good. Next, volume of a cone. Our formula is right here, 1/3 big B times H. Okay, so let's write down our formula. Same steps as we've always done. 1/3 big B times H. Let's come over here. It looks like they give us the radius and they give us the height. And that's all we need, really. Our big B, our base area, is a circle, so we'll do 1/3 times pi r squared, and in this case our r is 2.1 squared, and times our height, which is 6. So we've got our 1/3 right here, we've got our big B right here, and our height is over here. All right, again, I'm going to just put this in the calculator as 1/3 times pi times 2.1 squared times 6. And the answer comes out to be 27.7 meters cubed. Okay? And here's another problem if you want to pause, and you can solve that one yourself. All right, I think this is our last shape. It is the volume of a pyramid. And the formula, 1/3 base times height. That should sound familiar. Oh, it's the same as a cone. And cones and pyramids do look similar. They just have different size bases. So again, we're doing 1/3 big B times H. All right, so I'm going to bring down my 1/3. My big B is going to be area of my base. Our base is a rectangular shape. In this case, it's actually a square. So 8 times 8 is 64. Times our height, which they give us, is 9. So in my calculator, I put in 1/3 times 64 times 9, and I get the answer 192. And this would be centimeters cubed. And there's one more down here if you'd like to pause and solve that. Okay, so we need to summarize. We learned a few different shapes. Okay, the shapes we learned were prisms, and then we worked on cylinders. We looked at spheres, cones, and pyramids. All right, and to recap all of those, all prisms, the formula was just big B times H. Okay. For cylinders, our formula was big B times H. The only difference was, in this case, our base is a circle, so we do the area of a circle. Spheres were a little different. They were 4/3 pi r cubed. Cones looked similar to these two. It was just 1/3 B, big B times H, and pyramids are the same, big B times H. So when you break it down to just this, you can see that this really isn't a lot of stuff to memorize. As long as you understand how to find big B, you're going to be just fine. If you have any questions, feel free to text me or come see me early in the morning. Thanks for watching. Make sure you bring your notes to class.